Now we will have a session about the VNF onboarding, what it is, and also I'll try to explain what is the task and exactly what needs to be done. I know that all those previous sessions were packed with a lot of information and things might be confusing. So now we'll slow down a little and try to go over the bits and pieces that has to happen in order to succeed. So let's start with a generic introduction to what the onboarding actually is and what OSM is doing and what you guys will be doing over this week. So basically the OSM will be doing day 0, day 1, and day 2 operations for you. And what it means, day 0 is a basic instantiation and creation of the network function. Then you have the service initialization, so actually every activity that is needed to start running the service. And day 2, runtime operations is anything where you will be changing something in the configuration or doing any like additional things on top of a running network function. So where to start? You might be thinking, what I need to do if I'm new to it, what's this task about? So basically, what you need to do in the beginning is to build an initial package, which will contain the deployment descriptor and the charms that are necessary to deploy OAI. And in order to do that, like the first thing that you need to take a look into is what are the requirements of the particular VNFs. Because obviously, whenever you will be trying to create a VNF descriptor, you need to know if the particular container will require that amount of vCPU, that amount of RAM, maybe some IP addresses, and so on. So go over the tutorial and make sure that you know what are the requirements of all the particular things that you will be deploying. And then what you will be doing is writing down the deployment descriptor. So these wikis are open and available. They are on the osm.org website. And this is the like day 0. After having the charm and the deployment descriptor available, you can onboard the network function via OSM. Then we go to the day 1. So basically there are 2 ways of so the question I see here is, do we need to deploy a Juju charm or it has been deployed already? So no, it hasn't been deployed and it also hasn't been created. So the charm code is something that you will write as part of this exercise on the Hackfest. So Juju itself obviously is part of OSM, so all the tools are there. And I will show you soon how to make a development environment and the setup where you can code it. So basically, since we got a question about it, let's jump into it. So on the juju.is site, there is a documentation about the development environment. And when you go there under /doc/sdk/dev setup, so basically this particular link, the development setup is quite simple. So what you need to do is to install Charmcraft, LexD, and Juju. Your microcased instance is already deployed there, so the only thing that you need to do here is actually do the Juju bootstrap. And if you do it on the machine where your microcased cluster is available, you can start developing your code. About developing your code, that's also one important thing. If you are familiar with command line editors, since you are getting SSH access to the machine, like using tools like vMemax or MANO, then you are fine and you can develop directly on the machines that we provided to you. And if you are not and you prefer a more like GUI-like environment, you are working on like Windows daily and you are not that familiar with the command line, what you can do is to download the Visual Studio Code as an editor, and it has a possibility to edit via SSH. So basically, if you provide an address of the server, you will be able to see the file list and edit remotely. If you prefer any other editor, I'm sure that you will get a plugin for remote editing or SSH-based editing or any other name like this. I know that you will get one for IntelliJ and most probably any other popular integrated development environment as well. Okay, so jumping back to the days and day 2. So basically the VNF runtime operations, and this is part of your task where you will be doing the, for example, doing the configuration change. Here on that particular day 2 website, you will have some examples on how to do operations, like for example, automated scaling and anything additional. So this is also a nice place to look in for information. And last but not least, there are Quickstarts. So the whole OSM wiki provides several Quickstarts. The one that we will be looking for, since we are deploying on Kubernetes and we are deploying cloud-native network functions, there is a Squid one showing you how the Squid CNF is modeled with Juju bundles. So this is like a simpler example of how the day 1 actions look like and day 2 actions and so on. This is, by the way, available on the VNF onboarding repository. So if you clone that link, you will get all the code that is mentioned here in these examples, so that you can start off, for example, from here. What I also did is adding the task description here. So basically, this is the, I would say, the order which I would recommend or suggest you to start doing your task. Obviously, you are feel free to do anything differently. Like we are only doing the evaluation of the a final demo, not the process. We are here to help you during the process, but not forcing anything. So what I would suggest doing is first to test OAI deployment according to the tutorial that Sagar shared on the earlier presentation. So basically use the available Helm charts and Docker images in the repository and try to deploy entire setup to get familiar with different network functions, what are the configurations, and what else is needed. Yeah, LXD installed already. Yeah, that might be the case. So if something is installed already, you can skip a step in the documentation. So coming back to the order, after you test the standard deployment in the tutorial, then you can start implementing deployment descriptors and charts for your OAI network functions. And after you have that and you have a full deployment, you can use the last step in the tutorial, which shows you how to test an end-to-end setup with the simulators and validate if you are okay. If you are on this step number 3 and you still have a day or 2 left before the demo, then I would suggest the following order. So first, start with automating the configuration parameter change. This is the simplest day 2 operation. And this is something that you can start with. The next one could be a scale-up operation. So basically adding additional instance of one of the network functions. I would suggest the GNodeB RF simulator, at least like that's the one that I tested before, but it will probably work for anything else as well. And the last one will be an upgrade of an AMF. So you don't need to upgrade to any specific version, just redeploying it with a new version of a Docker image or other branch or something like that, just to have an automation that allows an upgrade of particular network function. So that would be the order that we would suggest you to start with. And now I would like to give the sharing rights to David for a second to give you some details about how this kind of charms typically look like and what might be necessary and if there are any pitfalls. So David, are you with us?
Yes, I am. Just give me a second, please. Can you hear me?
Yes, very well.
Okay. Okay, confirm me when you see the screen, please.
Yes, we see the screen as well.
I'm going to make it a bit bigger. Okay, so in the path and also in the, so if you can, Maciej, add the link to the GitHub in the path, I would appreciate it. I'm going to paste it in the chat too. But this this repository includes a bunch of charms that are that currently do not have any actions implemented, but they are pretty basic that will deploy effectively these components that we can see, the AMF, DB, NRF, SMF, and this other one. And basically these operators gives you the space to manage the life cycle of these applications. So right now we have integrate them between each other so that for example, the NRF needs the AMF. So there's a relation between these two charms which allows them to exchange data and connect to each other. So now I'm going to go to one of these and just go a bit through the files of how a basic charm would look like. But I won't go too much into detail. You can ask me any questions that you may have during the week, and I'll be glad to help. Just to point out or stress one thing. The good thing about the charms is that they will allow you to implement day one and day two operations very easily into OSM. So that's something to consider. Okay, so basically let's start. Let's take a look at three of the main files of every charm. So for example, this is the NRF, and there's one basic file that is the metadata.yaml, in which we express here some basic data about the name, the description, and so on, and also the containers that this charm has. That this charm has. One is the NRF itself, that is the application, and the other one is TCP dump. Well, this is the same as in the Helm charts and the guide provided by the OAI, so it's basically the same. And also here, this is important too. This says that it provides one endpoint that is the NRF. So when this operator is or when there's a charm requiring this, this can provide an NRF endpoint to allow others to integrate here. Okay. Also, we have the config.yaml, and this allows you to expose some configuration of the charm itself. And basically, there's only one option in all the charms, that is the start TCP dump, which is defaults to false. But you can add here more configuration options to make the charms more versatile. And okay, let's go here to the actions.yaml. There's no action right now, but you can find examples in the OSM packages GitLab repository in OSM. well, there are plenty of examples on how to include here actions, and yeah, basically that. And to finalize, well, there's the source charm.py file that includes the operator code for the charm. So it's basically a Python code with all the logic to handle the life cycle of the application, to start the services, the containers, to relate to different applications, and so on. I won't get too deep into this right now, but because the code is a bit self-explanatory if you take a look at it, and also there are a few links that we will paste into the path for the UU documentation, Perl documentation, and things like that that will be very, very useful for you. And you can also take this as an example, and it will be fairly straightforward if you want to, for example, include another application or integrate it with another application that is not in this bundle. And I think that's all from my side, Maciej.
Okay, thank you for that. Yeah.
Yeah, but again, if you guys have any question, I will be very glad to help you out or guide you through the process.
Okay, so I think we are done with the introduction part and the task description. So now let's jump in.
Can we ask something here, or?
Yeah, sure. So now we are jumping into a Q&A session. So feel free to ask any questions.
Okay, thank you. Yeah, I just have a question about the TCP dump analysis. Are there any built-in tools comes with the OI bundle? Yeah, because you refer to the TCP dump analysis, right?
The analysis you mean in the tutorial?
No, I mean the analysis of the TCP dump, like when you collect some TCP dump using the OEI bundle. So, are there any built-in tools comes with the bundle which can help in such kind of analyzing the TCP dump for security reasons?
So basically, in order to take a TCP dump, so every network function has an extra container to take the TCP dump. It's described in the tutorial from Sagar and the OAI team. And obviously, if you want to analyze the TCP dump, I think that the easiest way would be to just download it and open in a Wireshark client. Wireshark is an open source, sorry, not open source. I'm not sure now if they are open source or not, but Wireshark is freely downloadable from the internet, and you can use that to analyze the TCP dump.
Yeah, so I mean, it can be deployed with like the OpenShift or with the OEI bundle can be integrated with it. So I can just forward the TCP dump to Wireshark or TCP dump analyzers for security reasons, just to see whether there are any signature within the attack signatures within the packets.
So basically, Mark shared the tutorial on how to set up TCP dump.
Yeah, he sent the link.
Yeah, well,
so. Thank you, Mark.
That's specifically if you want to run Wireshark locally and capture remotely live. If you just want to do a TCP dump to a file and then copy that back to your computer, that's easy. I mean, that's just TCP dump. The other thing to mention is that you guys do have sudo permissions on both your OSM and your Kubernetes VMs. So any tools that you feel that would be helpful for you, you certainly are free to go ahead and install them. You have full control and full, root access, if you will, as needed.
Okay. Yeah, that's great. Yeah, so I think I can do the same for Snort or any other security tools similar to the Wireshark and TCP dump setup, right? Like Snort system or any other packet analysis tools can be installed in the same way. Right?
Yeah, so basically anything that you can do, apt install on Ubuntu, having a sudo access, you can basically install anything and you are connected to the internet. Like we would advise you not to mine Bitcoins on those machines. They are not powerful enough anyways, but basically anything outside of that should be fine.
Okay. Yeah. So and the main question here, is there a way to forward the output of this analysis to a certain virtual machine or a certain environment within the OII bundle or within the infrastructure?
Well, you can download it to your own local laptop or PC or whatever you are using.
Okay, thank you.
Any other questions or doubts, comments? Okay, I assume that you are then eager to start hacking. So basically, good luck with the, yeah.
May I ask a question? Sorry, and before the break, actually, you mentioned about changing the configuration on the value YML file, and because of the security difference in the OpenShift and the micro Kubernetes that we are using. So I missed that part actually. I don't know what is the changes we need to make in that file.
So the screenshots are available in Sagar's presentation. The change that needs to be made is just an IP address. So basically, whenever you deploy your network functions in the Kubernetes that you have available, there is a metal LB and you have a pool of IPs assigned to you. In the pod where you put your name into the team name and so on, there is a list of IP addresses. So the range, you can use any of the IPs from that range for your network functions, and the IP that you will decide to use, you need to update in the configuration so that the network function knows what address it should bind to.
Okay, thank you so much. Thank you.
Yeah, you're welcome. So another piece of advice for the end: start your hacking from a short call to introduce to one another, decide on who is doing what, and try to plan your work a little bit. This kind of additional 30 minutes in the beginning could be very helpful to synchronize, as some of the teams are quite big in size. And that's what I would advise you as a first step. This is also building a community. And if you have any questions during that meeting, feel free to reach out to us on Slack. And also you can invite us to a call that you have, and someone from the mentors will join and help you out. So thank you very much for listening to this debriefing, and good luck. Sylvia, any final comments?
No, just good luck to everyone. Have fun, first of all. Yeah, we are available on Slack, so reach out if you need any help. Talk to you tomorrow then, 3 p.m. Central European Summer Time. Bye-bye. Have fun.
Thanks, everybody.
Thank you. Bye.